All right. So 2.1 is the rectangle coordinate system. So basically the X and Y plane where you plot points. So just a grid system that you plot points on. Okay. It was named also called the Cartesian coordinate system after Descartes. The history was um, this guy was looking at the ceiling and thinking about points, which he was looking at a fly actually flying on the ceiling. And he's like, he said, "Well, I can create points to locate that spot, that point," and started creating his own system. So they named it after him. And the quadrants are counted counterclockwise. So this one right here is going to be one. So all the positive numbers, see how it goes one, two, three, four, five to the right on the X. Going up vertically is the Y. So that's one, two, three, four, five. That's positive. If I go down, that's negative. If I go to the left, that's negative. So quadrant one is all the positives. Quadrant two, X is negative, but Y is positive. Quadrant three, everything is negative. Quadrant four, you can see that the Y's are negative. Okay. So the first few questions in the homework and in the example is really just, can you plot some points? Can you give the numbers for the locations? Okay, so just real quick. You can see right now they're just saying, okay, well, here's the location. Negative 3, 5 right here. You can see that we went 3 to the left. The first one is always X. The second one is always Y. So you went 3 to the left and then we went up 5. You see that? One, two, three, four, five. So X, it's always going to be X first, comma Y. Okay. Now I'm sure you've done this many times. I'm just reminding you. Or if you haven't, well, this is the time to ask questions. Question one in the notes, get a location for London. So what is the location? What is the ordered pair? What is the point for London? What do y'all think? Yeah, it's going to be ordered pair. So we got to put the parentheses, 8, comma, 10. Negative 8, 10. So we went that way. Oops, this way. Does everyone see why it is negative 8 and 10? Okay. This is the time to ask if you don't. Okay. Now, before we answer this question, what quadrant is 2 comma 6 going to be in? Yeah, it's gonna be quadrant 1, right? Sure. So you're going to go to the right 2, the X is first, and then up 6, we're going to be right here. And this is quadrant 1, 2, 3, and 4. On the next one, they actually asked for the quadrants. Number 3, which quadrant is this in? You can make a little note to yourself to make it easy, or you can just kind of look at it. This is always plus plus. This is always negative plus. This is negative negative. Looks like an owl, kind of. Plus minus. So we got what? Minus plus? Yeah, for sure has to be 2. What about this one? Yeah, it has to be 4, right? And the last two? 1 and, well, actually, 0 is where exactly? 0, negative 2 would be right here, right? So we're not in a quadrant. We're on the axis. Which axis is this? Yeah, it's going to be the y. Move downward. So we said 2, 4, 1, y. Any questions on number 2 or 3? That okay? It's not too bad, right? I'm hoping 2-1 is pretty chill. And if not, just let me know. Okay. So at this point, they start asking about distance between points. And the way they derive this, which we're not going to do, is using the quadratic, not quadratic form, using the Pythagorean theorem to find the hypotenuse. Because check it out. Technically, right, you could draw a triangle and find the distance between the 2 points, which is the hypotenuse. So this right here is D, this distance. That's how they found this. They just find the distance from this, they find this length and this length by using x2 minus x1 and y2 minus y1, square them, square root to find D. But if you don't want to think about it, you can just plug them in and just label everything. This is my first point. This is my second point. And then you just plug them in here, and you're going to get the hypotenuse or the distance. Does that make sense? Do you see how they came up with that? It's kind of cool if you think about it. I'm gonna show the work on the paper. Let me switch over in just a second. This could switch now. Too many cameras. Sorry. All right. Find the distance between the points M equal to 0, 3 and C equal to 5, -1. The distance D formula says subtract the x's, square them, and then add the difference of the y's, square them. Label your points so you know what's what. So the distance will be x2 minus x1 plus y2 minus y1. To crunch the numbers here. That'll be 25 plus 16, right? Yeah, cool with the minor step I skipped from here to here. If not, let me know. Okay. What's 25 plus 16? Is that a pretty number? Me 35, 41. Yeah, thanks. So, is that square root pretty? I don't think so. Nah, that's it. And that's the distance. Do you want actual decimal? You punch it in your calculator. The question says not a decimal approximation, so you're gonna this they want this. All right, so I'm gonna move on to the midpoint formula. Any questions on the distance formula? All right. Yeah, we'll just do one of these and move on. Okay, midpoint formula. This time I'll write it out. It's in the notes, but uh yeah, let's write what they say. The midpoint of the line segment, sorry, with endpoints x1, comma y1 and x2, comma y2 is the following. So we'll use capital M for midpoint. All you got to do is add the x's, divide by 2, comma, add the y's, divide by 2. That'll give you the center point of the line segment. Okay. So find the midpoint M of the line segment. We'll say with the endpoints. C equal to 0.8 and D equal to 8, -4. So on the picture, they graph it for us. 1, 2, 3, 4, 5, 6, 7, 8. So at this point, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So they want to know what's the distance from here to here. It's prettier on the picture, but who cares? Just want you to get a visual of what we're doing. So label your points so we don't mess it up. M is equal to x1 plus y1, or sorry, x1 plus x2 over 2, y1 plus y2 over 2 is equal to 0 plus 8 over 2, 8 plus a -4 over 2. So 8 divided by 4, 8 plus a -4 is 4, divided by 2 is going to be 2, right? So this is the midpoint M. 4, 1, 2, 3, 4, 1, 2, about there. If it was a prettier drawing, it'd be exactly dead center, but of course, I'm not a printer, so. Any questions on example 5 or 7? We're just following the formula, trying to understand what it's doing. Okay, you guys good then? I'm gonna move on to the next section. Oh, actually, there's one last idea. One moment. I'm just gonna write you the note and then move on. To find the x and y intercepts of your function or equation, this is what you got to do. To find the x-intercept, let y equal 0 and solve for x. That will be the x-intercept, assuming there is a solution. For the y-intercept, you do the opposite. Let x equal 0 and solve for y. That will be the y-intercept. And that'll be it for 2.1. You have any questions on 2.1? Okay, let's move on then. Yeah, 2.1 is not too bad, right? All right, 2.2. Hold on a second. Let me pause it. Let me create another video for this part.